Today we are going to learn about functions. As you may remember from the chicken nugget video, the input is the domain or x values, also known as the independent variables, which go into the function machine. The range is the output, also known as the y values or the dependent variables. So therefore, a function is a relationship with one or more variables where each input has a single output. So in summary, with functions, each x value is only allowed to correspond to one y value. Let's look at the example below. As we look at the two tables on the left side of your page, we're going to start with the first one, and this relation is a function because none of the input values, or x values, have more than one different output value, or y value. So the first one shows that 0 goes in, and out comes y. 1 goes in, out comes 3. 2 goes in, out comes 6. 3 goes in, out comes 9. 4 goes into the machine, and out comes 12. None of the x values have repeated themselves. As we move to the second table, this relation is not a function because at least one of the input values, or x values, has more than one different output, or y value. Take a look here. -3 goes in, out comes 1. 2 goes in, out comes 5. -3 goes in, out comes -1. 5 goes in, out comes 2. 8 goes in, out comes -2. So clearly, we can see that -3 has two y values. This makes it so that this relation is not a function. When we think about writing function notation, you will see f of x in place of y. How to say that out loud, again, is f of x. So as we evaluate a function for a particular x value, just plug in whatever they give you for x and then simplify or solve the equation. So the example says if f of x is equal to 2 times x plus 1, let's find f of 3. So our work shows f of 3 is equal to 2 times 3 plus 1. What do we get? That's right, 7. 2 times 3 is 6, add 1 makes 7. To determine whether a relation is a function, there are several different strategies that we can use. We are going to add circles, arrows, or lines to demonstrate why each relation is or is not a function. So if we use a table to look at a function, review the columns. The relation will not be a function if any x value corresponds to more than one different y value. Try A and B on your own. If we are looking at set notation, you are going to review each ordered pair. The relation will not be a function if any x coordinate corresponds to more than one different y coordinate. So take a look at sets C and D on the right and choose yes or no for is it a function. The third strategy uses a graph. We will have to use the vertical line test. The relation will not be a function if a vertical line ever passes through more than one point. So on graphs E and F, go ahead and draw your vertical lines and then choose yes or no if it is a function. Lastly, for mapping diagram, we are going to review the arrows. The relation will not be a function if any x value maps to more than one different y value. So take a look at the diagrams on the right. Go ahead and decide yes or no if they are functions. To wrap things up, we are going to practice finding the domain and the range. We know that the domain is the set of all possible x values. We also know that the range is the set of all possible y values. So your job here is to identify the domain and the range of the relations in the table, set notation, and graph examples above. Look at A, B, C, D, E, and F and identify the x values and the y values. Using Table A as an example, I will write the domain starting with brackets, list all of the x values, and then close with a bracket. For the range, again, start with a bracket, write down the y values or outputs, and then close with another bracket. Please repeat that with B through F. Lastly, we want you to try it. Create a mapping diagram with x values and y values that represent a function. Then, you can use the same values or new ones to create a graph that also represents a function. See you in your next class.